Hello, let's talk a little bit about unit conversions and we'll get into significant digits. So what I've got here is a yardstick, and this yardstick is 36 inches long, right, from end to end. And if I said, hey, let's convert that into feet, you'd say, well, hey, 36 divided by 12 is 3. So it's 3 feet. And that's kind of correct, but it really isn't. If I were to divide this by 12, what I would really be doing is cutting it into 12 separate entities, right? That's dividing this by 12. If I break it in half, I've divided it by 2. I've changed the length when I've done that because now I've got 2 different lengths, right? So you can't just multiply or divide by a number to do a unit conversion. What you have to do is multiply by 1. Why? Because if I multiply by 1, I don't change anything. If I take 36 inches and I multiply 36 inches times 1, I get 36 inches. Nothing has changed, right? So if I take 36 inches and I multiply by 7 over 7, guess what I'm going to get? I'm going to get 36 inches. The length of the ruler is unchanged because I've multiplied it by 1, by unity. If I want to convert this into into feet, I need to multiply by 1. Well, the conversion that I do is 12 inches in the denominator is 1 foot in the numerator. The numerator and the denominator are identical. This is 1. This is 1. It's not 1 foot, it's not 1 inch, it's 1. And so I haven't changed the length of my ruler when I've done that, right? And so what do I get? I get 36 times 1 over 12, there's my numbers. I get inches times feet, right? Inches times feet divided by inches. Well, if I do that, the inches go away, and I'm just left with feet, and 36 over 12 is 3, so I got 3 feet. Okay, so that's how we do unit conversions. That's how we do unit conversions. All right, so now let's go to the next phase, and let's do a little bit more complicated unit conversion. All right, so what I'm going to do is I'm going to do a problem. And in this problem, I have an object that is 3.867 kilograms in mass, moving at 79.3 miles per hour. Right, so there's this object, and it's moving, and what I want to do is calculate the kinetic energy. Now, the equation for kinetic energy is 1/2 mass times speed squared. Okay, but you'll notice that this speed is in the English system, okay, and this speed, or this mass, is in the metric system, so I want to make a conversion. So maybe part A of this problem is convert 79.3 miles per hour into meters per second. Okay, I'm even going to label this part A. Convert that speed into the metric system, meters per second. How am I going to do that? I'm going to start off with 79.3 miles per hour. MI is the symbol for miles. H is the symbol for hours in physics and engineering. Okay, those are the abbreviations or the symbols that we use. All right, so I need to convert. I'm going to multiply by 1. The first conversion I'm going to do is for the hours. I know that 1 hour is 3,600 seconds. Right? So the numerator there and the denominator are the same. They're identical. And so this is 1. It's not 1 hour, it's not 1 second, it's 1. So I've multiplied by 1. I haven't changed my speed in any way, shape, or form. I'm just making it look a little different, but it's the same speed. This object, this 3 kilogram object, is traveling down the road at 79.3 miles per hour. I haven't changed anything yet. All right, so there's that. Then the miles. There are 5,280 feet in 1 mile. Right? Well, now I've gotten it to feet, but I need to get it into the metric yet. So let's see. 1 foot is 12 inches, right? And then 1 inch is 0.0254 meters. Okay, so 12 inches is 1 foot, this is 1. 5,280 feet is 1 mile. They're identical. Numerator equals denominator. This is 1. 0.0254 meters is 1 inch, right? That's all by definition. And so when I'm done doing that, I get, when I work all of this out, I get 35.450272. That's what my calculator spits out. Now, let's look at units. So I've got miles over here, cancels with miles there. Hours up here, cancels with hours there. Feet, cancel. Inches, cancel. I'm left with meters in the numerator, seconds in the denominator. So this is meters per second, right? That's meters per second. All right, so there's my answer. Now, I'm interested in significant digits, so let's take a look at that. 793. 1, 2, 3. There are 3 digits here. There are 3 digits in 79.3. That means I know the answer down to 1/10 of a mile per hour. Right? That's how precision, that's how precise my measurement is. By definition, 1 hour is 3,600 seconds. So this is an infinite number of digits. By definition, 5,280 feet is 1 mile. Infinite number of digits. Infinite number of digits. Infinite number of digits. By definition, this is a good one to have in your back of your brain here. 2.54 centimeters is 1 inch. By definition, right? It's not an approximation. This is how we define the length of 1 inch in terms of the meter. By definition, 2.54 centimeters or 0.0254 meters is 1 inch. All of that's by definition. So when I look at the number of significant digits, I have an infinite number in all of these and 3 over here. So when I calculate out my value and I want to write out the actual value, I look at the least number of significant digits. The least number of significant digits, and that's the 3. And so this is going to be 35.5 meters per second. And that's my answer to part A. That's my answer to part A, because I write it out in the proper number of significant digits, which in this case is 3. All right? Now, let's do part B. In part B, I want to calculate the kinetic energy. So the kinetic energy is 1/2 mass, but my mass is 3.867 kilograms. And my speed is, and this is where life gets interesting, what do I use? If I use 35.5 meters per second, and I'm squaring all that, if I do that, my calculator spits out 2,436.69, and that's going to be kilograms meters squared per second squared. Right? That's what my calculator is going to give me. If I do 1/2 3.867 kilograms, but I use 35.450272 meters per second, my answer is going to be 2429.87 kilograms meters squared per second squared, which by the way is a joule, but we'll get to that later. So here's the deal. How many significant digits? If I look at this, I've got 3 here and 4 here, right? So 4 digits on this term, right? 4 digits on the mass, 3 digits on the speed. And so I round this off to 3 digits. Well, if I do that with the top one, I get 2440. And if I do that with the bottom one, I get 2430. Those are not the same, not to 3 significant digits. Remember, this number here looks like a lot of digits. It looks like I've got 4 digits here, but here I've got 1, 2, 3, 4, 5, 6, 7, 8 digits, but I don't. I really don't have 8 digits. This is my number that I should be using, but remember, the root of this number, the origins of this number, come from the 79.3, which is 3 digits. And so my final answer would be 3 digits. If I round off and then use that, I get a different answer, than if I use the actual answer my calculator spit out. And this is the method that we want to use. We want this right here. So the kinetic energy would be 2430, not 2440. So anytime you use a number that you've converted in a future calculation for a problem, use all the digits your calculator gives you. Don't round off in this middle of these calculations. Round off when I ask you, hey, what's the part A answer is 35.5 meters per second. Round off because you're giving me an answer to my question. But when you're answering the second part of the question, or question number 2, I'm not going to use 35.5. I'm going to use 35.450272. This is the number that I use when I go to calculate the kinetic energy. So don't use an intermediate answer, a rounded off answer. Use all the digits your calculator spits out when you go to do the next part of this question. All right? So I hope that gives you a little bit of an idea of unit conversions and significant digits. If you have any questions, please leave them in the comments below. Thank you.